The title of this presentation is very appropriate. Everything you always wanted to know about the ice, but were afraid to ask. So don't be afraid. So in this presentation we are going to talk about biological indicators, the selection, lethality studies, use of multiple BIs for each location, also statistic evaluation, and also at the end questions. So, what are they? Good question. We will answer. Why do we use them? Another good question. And then, what do they tell us? First of all, we have to consider that a BI is a living organism. So it is an indicator and it is not an absolute. As it is a living organism, mathematics cannot be applied, you know. We have to apply statistics. So BI, we have to use them because we have to challenge our process. We need to have a challenge that show us that the process is able to reproduce and to achieve the target of killing a certain number of spores. So BIs therefore are the primary indicator of the process effectiveness during cycle development and validation activities. But don't forget that all biological systems are intrinsical variable. So the BI's manufacturing process is a complex and is thoughtful that out of a production of hundreds of thousands of units of all them always react in the same way. Remember, live organisms. They can react in different ways. So variation and outliers are inevitable. And it is requires a statistical approach to evaluate the process lethality. So statistics. I'm not very good in statistics. But anyway, I try to do. So how they are made? They are made. The ice, they have generally they are made of a standard substrate of stainless steel 304 or 316. They have to be. So we are talking of the eye dedicated for surface decontamination, because if we are talking of the eye dedicated for steam sterilization, they can have other different substrate. Okay. So they need to be simple to be produced, does not absorb and react with the biocide. So stainless steel is a good compromise. does not absorb, representative of many components and surface of the equipment, easy to inoculate and dry, does not impact spore viability, not affect on growing media. So when you make the inoculation in your growing media, the substrate does not have any effect. The substrate preparation. You need to have a very nice finishing of the surface, because if you have a surface with cracks and crannies, then your spores are hidden, and the vapor or the steam or the gas or the dry mist, they are not able to penetrate, and therefore they are not filling your spores. The ice size suitable for the application. This means that the ice can be also produced in thin ribbon, so to be introduced in a hidden place, or even can be produced in wires. So if you want to check if you get the contamination of inside a pipe hose, then you can have this BI on a ribbon, or sorry, on a wire. So you need to clean carefully, rinse, and then some of the manufacturers also they apply a sterilization process to eliminate any trace of biobord, existing biobord. So now maybe I'll give some answer to the people, the guys that wanted to know which kind of microorganism. So the microorganism demonstrate moderate. The microorganism has to demonstrate moderate to high resistance to the biocide, stability over time, perform linear kinetics, more the exposure time or concentration of biocide, more the increase in depth of the ice core is achieved. So high resistance is for single agent. Great resistance then bioburden in the environment to be processed. So BI is a challenge. So you are designing a cycle on an overkill base. So if we are able to kill very resistant bugs, then for sure we'll kill all the bugs like vegetative form or yield mist that is normally, you can find normally in your bioburden, in your factory. They should have low pathogenicity because you are handling this microorganism and you don't want that the humans and the animals are affected. So what are the, this is, I can escape. So here we have a reference table. The hydrogen peroxide, the Bacillus thermophilus, and the reference is the USP pharmacopoeia. The acetic acid, you can use both Thermophilus or Bacillus atrophius. And this is a report in TBA technical record. Chlorine dioxide, Thermophilus or Bacillus atrophius. So how much spores do we have to apply? At least 10 power 6, 1 million. suitable for 12 log reduction studies. There are some BIs, multiple BIs. So a BI, normally a BI has one disc of stainless steel. This is the package of this BI. There are some other BIs with a larger package in the same BI holding 3 discs that are separated but in the same BI. And one disc is 10 to 6, the other disc is 10 to 5, and the other disc is 10 to 4. So you have a kind of bracket of population in order to understand better the log reduction that your process is giving to the BI. And of course, they are suitable, characterized larger employment as well. This is for the guys that like to make the decontamination of the roofs. Anyway, question to you. These are 3 different inoculation of spores of 3 different manufacturers. For sure, 2 of them, they will give us some problem of growth because the spores are not very well spread. So this is not good. This is so and so because the surface seems not to be very good, and this is good. So this is good, so and so, not so good. So how can I make the inoculation on the substrate? I start from a spore diluted in a solvent, and then I put on my coupons a drop of the suspension. Then I make the substrate dry at room or higher temperature on a static or a dynamic environment, and then I check for the uniformity. The solvent is the key issue because DI water can create a lot of problems because of the surface tension of the water, and I'll show you in a minute. So we need to create a monolayer of spores, because if we don't get a monolayer, happen the rouge BI. And this rouge BI is a kind of cluster clamps that are very difficult to kill by surface decontamination process. This BI will have a log reduction of 50. So it's almost impossible to kill because of the configuration of the spores. And here another example of good BI, and the good BI is which one? Alpha? Yes, alpha. Okay. I was telling you about the solvent. If you have a solvent with a high surface tension, like this, then when it dries, it's like this. Do you think that the spore distribution is fine, or you can have clusters? Or SPECT. So you need to use a solvent that has a lower surface tension in order to create, when it is dry, like a pizza of spores. And here, inoculation of different material. So we talk about the substrate, we talk about the inoculum, now we talk about the packaging. The packaging is an envelope made of which material for you is good for the envelope. We already talked of this material in the previous presentation. Very permeable to hydrogen peroxide. What is? Anyone remember? Getting rid of aeration out of this material. Tyvek package.